This video explains the live load example for non-trafficable roof required to calculate the live load Q for a typical purlin that need to be designed. The purlin span is 5000 millimeters, so if you are taking the span in 3 dimensions, that is 5000 millimeters, and are at 1200 millimeters distance between one purlin to the next purlin, and the pitch of the roof is 15 degree. So this is the figure where we have these purlins, and we have rafters here which is 15 degrees at the pitch. Now first like to explain the non-trafficable roof. Now there are two kind of roof. One is non-trafficable roof, that is maintenance for they carry the load for the maintenance person, and also carry the any equipment that is installed on the roof, which is air conditioned unit. So non-trafficable roof is just a roof which does not have a regular access. So those are non-trafficable roof. For example, if I take the picture of non-trafficable roof, this is the typical picture of non-trafficable roof, where we have a air conditioned unit or any electrical equipment that can be installed on the top of the roof, and they carry the load for those equipments. And also maintenance equipment can be also placed on the roof, so they should also carry safely those loads. Now trafficable rules, for example, car park, regular access by people and regular access by vehicle. So this kind of loading should be considered in the design of trafficable roof. So for example, the trafficable roof can be shown in this picture, as we have a roof which we have a car park for the various vehicles. Now that's the difference between non-trafficable roof and the trafficable roof. Now this examples is in the category of non-trafficable roof and need to require the live load. Now first of all, it has a roof is 15 degree and it has 1200 millimeters. So if I can show it here, it has this length 1200 millimeters at 15 degree. So I draw this 1200 millimeters and 15 degree. Now we are interested in the projection length, whatever this 1200 millimeters, what is this horizontal distance. So that can have a cos relation, cos 15 equal to horizontal distance over 1200 millimeters. So this horizontal distance is equal to 1200 times cos 15. It gives us 1.1 meters. Now the span of the purlin is 5000 millimeters given in the question, so it will be just 5 meters. And then if I like to find the area which is on this projected area, which is 1.15 times the span 5, which is 5.795 meters square. Now this plan projection surface area, this is the plan projection surface area. Now that is given in the Australian standard AS NZS 1170.1, where we have a note number 2 on below the table number 3. We have this plan projection of surface area, that is A, which we going to use it here in the calculation of this live load. So this capital A is the plan projection surface area. Okay. Now the next we like to calculate the live load, which has an equation 1 over area 5.795 plus 0.12, and now this equation is coming from table number 3.2, other roofs, that is non-trafficable roof. And if I like to find the live load for the non-trafficable roof, that has an equation 1.8 over A plus 0.12, and there should not be less than 0.25. So 0.435, and that is greater than 0.25, that is okay. Now we like to find the load in UDL. So once we calculate pressure, then times the length. So we have this 0.431 times the length 1.159, that's we calculate projected length is equal to 0.5 kilonewton per meter. And the concentric load, that again we can use it from the table. From the table number 3.2, non-trafficable roof, we have a concentric load of 1.4 kilonewtons, and we can check this this note number 3, which is the structural element in roof of the houses or uniformly distributed shall be 0.25 kilopascal and the constant load shall be 1.1 kilonewton. So we are just taking this 1.4 in our case, which is concentric load equal to 1.4 kilonewton. So these are the two answers. Thank you very much.